All right, we are starting again yet for the third time of creating this video. I will get it right this time. We are doing a mini lesson on factoring trinomials. This is lesson A10E, and I'm covering it up because I've already done some parts. They're erased, but you can kind of see the phantom erase marks. We're going to go over how we learned this to do this in class, but then we will also incorporate some Desmos into it. So our first step in factoring a trinomial is to always look for a GCF. Do not forget that's always going to be your first step. In this case, we see 6, 19, and 10. While 6 and 10 do have a common factor of 2, meaning both of them are divisible by 2, 19 is not. Therefore, I cannot say the common factor is 2 of all three. So there is no GCF for here other than 1, so we move on to my next step. I'm going to go ahead and identify my A, B, and C. A is 6, B is 19, and C is 10. From here, remember, we move on to my box. And again, some of you may be able to see my phantom erase marks, but we're moving on. A times C on top and B on the bottom. A times C is 60, B is 19. All right, so I'm going to move on over here to find, I'm trying to cover it up so you can't see, to find what factors of 60 can give me 19 when either added or subtracted together. So I like to create my little chart on the side. I'm a visual person. I know 1 and 60. I know 2 and 30. I know 3 and 20. 4 and 15, 5 and 12, 6 and 10, 7 does not, 8 does not, 9 does not. Therefore, we stop right here at 6 and 10. So I want to see out of these pairs, which will add or subtract to give me 19. Because it's positive on top and positive on the bottom, I know both my sides are going to be positive, meaning we're really adding them. And 4 and 15 are those magic numbers that add to give me 19, but at the same time, multiply to give me 60. So then we move on to our box. On your box, A times C goes, AX squared goes in the first square, and then C goes in the last one. C, not 10. 10, not C. Okay. These magic numbers are the ones that fill in the boxes right here. And then I use my first row and find the GCF of 6x squared and 4x. The GCF of 6 and 4 is 2. 2 goes into both of those evenly. And they both share at least one x. So 2x is the GCF. I'd send backwards. What times 2x gives you 6x squared? Well, that's 3x. 3 times 2, 6. 6x times x squared. What times 2x gives you 4x? 2. And what times 3x gives you 15x? 5. 2 times 5 comes out to be 10. So my factors are 3x plus 2, 2x plus 5. And so to check this on Desmos, I'm going to make sure that this equation up here is equivalent to the question I got right here. And I just lost my Desmos. There we go. So I'm going to type in 6x squared plus 19x plus 10, and it should be equal to this one right here, meaning, just like we did on the warm-up, it gives me the exact same thing, 2x plus 5, the exact same graph. And indeed it does. Moving on to the next part, it wants to decide which students are correct. Notice each student gives me a different type of answer. Ayla says 3x plus 1 is a factor. Axel says 4x plus 1 is a factor, whereas Azul says 6x plus 1 is the equivalent expression. Each of these meaning different things. This is a factor. This is a factor. So both Ayla and Axel gave me parts of the final equation. We could work it out by hand and see which one is right, but I'm going to go ahead and show you the Desmos that you can do for this. If I want to see if 3x plus 1 is a factor, this means it goes through the x-intercept, it goes through the 0. As well as this one. So these both mean the same thing. A factor means it goes through the 0. Whereas the expression is equivalent, it means it's the same graph. So we're going to type in my original equation to Desmos. And then each individual part. And this ends up being a look and see into Desmos. Either my factor goes through the x-intercept, or it is equivalent. Let me show you what I mean. So we're still looking at this first one. If I were to type each of these in separately, 3x minus, or plus 2, plus, notice it goes through the x-intercept, as does 2x plus 5. Also goes through the other x-intercept. Therefore, they're my factors. So if I take that all into consideration and try doing this one right here, 12x squared plus 11x plus 2. I'm going to go ahead and zoom in since I'm looking to see if it goes through the x-intercepts or through my zeros, so I can specifically look at those x-intercepts. And I'm going to type in what Ayla put. Ayla. 3x plus 1. Notice Ayla's does not go through the x-intercept, therefore Ayla is not correct. So we're going to try Axel next. 4x plus 1. And if you zoom in, you can see that it does indeed go through the x-intercept. So as of right now, Axel seems like a good contender. Let's see if Azul is a match. This time, remember, it says equivalent, meaning it has to be the exact same graph. So 6x plus 1 squared. Oh, nope, not correct. So Axel is the one who is correct. All right, try 2 and 3. Same process.